All right, so this is our last section in 10.6, and it's all about related rates. So what we're doing is we're taking our implicit differentiation procedures and processes, and we are actually finding values. So we're looking how things are related in terms of their rates. So there's going to be, what you want to do is you want to kind of walk through a logical process whenever you read these. I'm going to show you one that's just directly, and then we're going to do a couple word problems so that you can see the connection. So first thing you want to do is you want to ask yourself, what is being asked? In other words, what am I looking for? With these, you're going to be looking for the rates of the cost, the rates of the profit, the rates of the revenue. Anytime you hear the word or you read the word rate, you know it is a derivative. Okay, so a rate is a derivative. All right. The second thing is, what do you know? You're going to be given information. You're going to say that there are, 500 radios. You're going to say that the rate that the radios are being sold is, 15 per month. So you have to look for that information in the word problems. If it gives you a specific value for an item, that's usually going to be your x value. So you have to look at the function or the equation and go, okay, what do the variables represent? That will help it tremendously. And then the third thing you want to look for is, what's the connection? The connection is always going to be the equation. So for instance, in the last video, I talked about when you're looking for the rate, you have the rate that an oil spill is growing, and you want to find the area. Okay, so I can tell you the rate that it's growing, that's a derivative, and I want to know what the area is after so many hours. Okay, so you're going to be given information, so the connection is the area function. Area equals pi times r squared. So whatever the function is, or whatever the equation is, that's going to be the connection, and that's what you're going to use to be able to do implicit differentiation. Okay, so here is our function. It's just a given one. It's not a word problem yet. You're given the function y equals x cubed minus 3. We know the derivative of x in terms of time. So this is the big key. With related rates, it's always based on time. So your cost is based on time. Your profit is based on time. So your variables are going to change. This is where that implicit differentiation of saying d dx, d dt, dt, whatever it is, comes into play. Okay? When x is 2. So the rate that x is changing in terms of time is -2. That means it's decreasing. When x is 2, and I want you to find the derivative of y in terms of time, or in terms of t. Okay? So this right here is going to be your key. What we're doing, we're going to go through the same process. Now I'm looking for the derivative in terms of t. Whatever variable is on the bottom, that's what you're going to use. So derivative of y, in terms of t, equals the derivative of, I'm messing up my colors, hang on. The derivative in terms of t of x cubed, and then minus the derivative in terms of time of 3. Okay? So this is what I was saying. Whenever you see that the variables are different, you are going to have a noun, a dx dt, a dy dt, because you are using the chain rule. So here we go. The derivative of y in terms of t is dy dt. And again, I got that because the derivative of y is just 1. Right? There's a 1 here, so I bring it to the front, and then when I subtract off, I get y to the 0, so it cancels. So this is dy dt equals the derivative of x cubed in terms of t. So again, we're going to use the chain rule. The derivative of x cubed is 3x squared, and then dx dt. Okay, so I peeled this off, and then I'm finding the derivative of x in terms of t. And then minus the derivative of 3 in terms of t is just 0. Okay? So if you look back, the connection was this function. We're looking for dy dt, and dx dt is -2 when x is 2. So we're given some information. So now I can plug it in. I'm looking for dy dt, so that's already by itself. My x is going to be 2, so I have 3 times 2 squared. My dx dt is going to be -2 because that's the information that I'm given, and then -0 just cancels. So I have, let me rewrite it over here, dy dt equals, so 3 times 2 squared is 4, so 3 times 4 is 12. 12 times -2 is -24. So in this case, the rate that the y is changing in terms of time is it's decreasing by 24 seconds, 24 hours, whatever the unit of measure is. Okay? So let me erase this, and we'll do one more, just straight, and then I'm going to stop this video and we'll do some word problems. All right, so our function is given x squared plus y squared equals 41. Our dx dt, so the rate that x is changing in terms of time is -5. When x equals 4, and they want me to find dy dt. Okay? All right, so here we go. We're going to do d dt of every term, x squared plus d dt of y squared equals d dt of 41. Okay, so implicit differentiation. These variables are different. So I'm going to find the derivative. I'm going to peel the 2 off. So the derivative of x squared is 2x. And then dx dt. Okay, so I peeled that off, and then I end up with dx dt plus, again, my variables are not the same, so I'm going to use the chain rule. 2y dy dt, and then the derivative of a constant is 0. Try to keep my colors the same. Oops. Okay, so now we know what x is, and we know what dx dt is. So I'm going to put my values in. So when x is 4, the dx dt is -5. And dy dt is what we are looking for. Now, this one we have a problem. We have 2 variables. Dy dt is one variable. That's what we're actually looking for. But we also have a y. We have to figure out what y is. So this is where the connection comes in, where you have to find a connection. If I go back up here, what function does this remind you of? So we talked about that it's the function of a circle. That is true. But it's also the Pythagorean theorem. Well, we know what x is, which means we can find out what y is. So we're going to have to come off to the side here. When x is 4, we're going to be able to figure out what y is. So we have 16 plus y squared equals 41. We're going to subtract 16 from both sides. So I have y squared equals 25. And then I'm going to square root. So y equals plus or minus 5. Okay, so we have 2 different things going on. We have when x is +5 and when x is -5. We're only going to deal with the positive version. Okay? We don't want to deal with the negative version. All we want to deal with is the positive version in these cases. So we're going to be able to take the y out now and plug in our 5. Now we have dy dt all by itself. So 2 times 4 is 8. 8 times -5 is -40. 2 times 5 is 10. Still looking for the dy dt equals 0. We're going to add 40 to both sides. So we have 10 dy dt equals 40. And then I'm going to divide both sides by 10. So, excuse me, I get dy dt equals 4. Okay? So that's another example of using implicit differentiation and using related rates. So with this one, we were given 2, but we needed to find the y. So sometimes you have to stop yourself and go back to, okay, I might need another variable. We had a variable here that was still unknown. You can only solve one equation with one unknown. All right, next time we'll do related rates word problems.